Okay, so let's get going here with this. So polygons with inscribed shapes. So what's going to happen here is that you will focus, the focus will be on, first and foremost, the big polygon that is created by the outermost sides. And then I will throw a curveball at you by inserting diagonals. And those diagonals create new shapes that we already recognize within that polygon outside. Okay, so this is that diagonal. Okay, and we know that the number of sides here, we would not count like 1, 2, 3, right? We wouldn't do that. The diagonal is omitted when you figure out the number of sides. The number of sides here is 5. It's a pentagon. That's what you focus on first and foremost. Okay. All of the polygons that I'm going to be giving you are going to be regular when you do these kinds of questions. Okay. So what do you have on top? What kind of shape do we have on top? What kind of triangle is that if two sides are congruent? Isosceles, yeah. Isosceles triangle. And at the bottom, this is actually an isosceles. What kind of shape is that, do you think? Trapezoid, have you heard of that? A trapezoid? Yeah. Some classrooms have desks that are like in the form of a trapezoid, right? So you've got, the keyword is that it's going to be isosceles something, right? And so that's what happens there. Let's look at the other one here. I want you to first and foremost focus in on the outside, because remember those formulas I gave you, like the psyched ones, right? As long as you have the number of sides, we have in this case 1, 2, 3, 4, 5, 6, 7. That is key because that will give you a number for angles, right? Do you notice that there are no angles given? That's going to be the case, right? So you're going to be stuck. It's like, I need numbers, right? You can find them, okay? So at the top, we have an isosceles. Now you know that one, right? What is that? An isosceles? Trapezoid. How many sides does it have? 4 sides, right? Quadrilateral. It's actually under the quadrilateral family. Isosceles trapezoid is that specific quadrilateral. And this one is an isosceles what? It's actually a pentagon. Isosceles pentagon. And you're like, pentagon? Didn't you say 7 sides, Mr. Hicks? Yeah. So this is a pentagon because if you now just focus in on that shape created by this diagonal, it's almost like cutting it. You count 1, 2, 3, 4, 5, right? So it's almost like what's going on there, right? So inside here is n is equal to 5. Inside here is n is equal to 4. Okay. And so here I'm going to give you the 3 most common shapes that you will encounter just underneath. Okay. First, isosceles triangle. I want you to know that when 2 sides are congruent, right, that these 2 angles will obviously, they will match, right? These will be the same. So this is going to be the different angle up here. And so I want you to highlight that A with something. I don't know what works for you. But I will tell you that, and you'd have to agree with me. You don't have a choice. To find B, we would just go 180 minus 2 times. Sorry, yikes. Yeah, this is supposed to be A, guys. I'm already thinking of the weekend, okay? So give me a break. No. Oh, come on. Let me get this straight here. I now got it. Okay, I just have to calm down here. B is 180 minus A divided by 2, right? Sorry about that. Seriously? Okay, let's focus again. Let's focus. Sorry, like just erase that what you just heard, right? So B, these angles would be found by going 180 minus this one up here, right? You take this one away from 180 and the remainder you split it in half, and then you actually have angle B, which they're both the same, correct? And so I will highlight the A in here just so you know that that one comes in there. I think as I'm racing against time, that's so just calm down, right? And then I'll tell you, I'll say, hey, let's apply what we just learned to an isosceles trapezoid. And again, right, these two angles, the base angles in this case, are the same. And notice that these are also the same. Isn't that interesting, right? These are if you zoom into this shape, for example, right? It's what do we call these ones here when we look at that polygon? At this one and this one, look up on aren't those the interior angle of the pentagon, right? This one is the interior angle, this one is the interior angle. So same here, these two are actually end up being the interior angle of that bigger polygon that's going to be surrounding it, okay? So in this case, to find angle B, we would go, what number would we use instead of 180 for a four-sided shape? 360 minus, this is where it gets different, it's minus 2 times A, all of that divided by 2. And I introduced the brackets because if you don't do the brackets, you're going to get the wrong answer if you just type it in one shot. And last but not least, the isosceles pentagon. This pattern continues for shapes following. So to find angle B in this case, right, you'd have to go, what is it for a pentagon? If you did that table, what's the sum of angles in a pentagon? 540, right? Do you remember that? It is always 540. Any pentagon, if you go to that table, minus, how many A's are there in this case? 3 A's divided by 2. And so these formulas are going to follow us in what we do next. And I will just do this here again. I will highlight all the A's and just make sure you understand the pattern, right? That's happening all the time. And watch this. This is the big finale on this one. All of the A's here are actually the interior angle of the big polygon that's surrounding these shapes. Okay, so if you box this in, I'm going to use a red pen and link it. So in this case, that would give you that A that you're looking for there, or the A in this case, or the A in that case. Right? So A in this particular instance represents the interior angle of the bigger polygon. So write this down here. Angle A is the interior angle of the main polygon. This is like a note here. So here's what we're going to do. If I happen to run out of time, you're going to leave, right? I will finish the video, right, to make sure that example is completely finished, okay? If that happens. And so then I want you, for homework, I want you to figure that out. All right, next, let's go to the backside, and if you can, leave this open, right? Leave this page open so you can refer to the formulas that I just gave you, right? So as we do this example, you can right away look at the formulas I gave you. Okay, so let's focus on this one. So here is our main, this is the main polygon in question. How many sides are we looking at here? 1, 2, 3, 4, 5, 6. 6. Okay. The first thing I'm going to do is I'm going to figure out angle A here. Angle A is what? What does it happen to be in this case? It's actually the interior angle of this main polygon. So in fact, you would just go 6 minus 2 times 180 divided by 6, and that's just 120 degrees. So angle A is 120 degrees. We've got that covered. Just be careful that it's not going to always be called A, all right? This could be called X, Y, Z, B, L, M, N. You get it, right? So, but it happens to be the interior angle. So this is, right? I'm figuring that out. Next, I want you to do this. I want you to focus on this diagonal here. Okay? And this is an isosceles triangle. Okay, this one right here. Do I know one of the angles in that isosceles triangle right now? Do I know it? It doesn't look like it at first glance, but wouldn't you agree that this angle is the same as this one here? Is the same as, right? So this is 120, but so is this one up here. So you do know one. You do know one, okay? So how would we figure out angle B? And remember, this isn't a regular polygon, so these two sides are the same, which means that this angle will be the same as that one, correct? But I'm just going to focus in on this one here. So angle B is going to be 180 minus the 120 that I found, divided by 2. Right? And so that ends up being 60 divided by 2, which is 30 degrees. So angle B is 30 degrees. Okay. And now we're going to figure out, let me just write down this isosceles triangle, right? That's what I'm finding there. And last but not least, angle C. How would I do angle C? This is a little crowded, so I'm just going to go arrow, okay? Arrow in there. I just figured out that this angle is 30. And I actually figured out that this angle there is 30 as well. You did both at the same time. You're with me? I just need you for a couple more minutes. At this corner right here, if you focus on from green to green, what angle is that? The interior, you got that? That's the interior of this polygon. What is this big one here? We already know is 120. What am I going to do to get C? Minus 30, but I'm going to do this in your notes, okay? I'm going to go minus B, which in turn ends up being 120 minus 30, which is 90 degrees. So angle C is 90. Okay? So one quick note here. 1, 2, 3, 4, 5. What is this one here? This is an isosceles pentagon. if you have a choice, I would start with the smallest one. We could have used the isosceles pentagon. Look at the formula on the other side. Or we could have done this, couldn't we? We could have figured out C, angle C is what? 540 minus, we have 3 120s up here, correct? Because this one is the same as that one. We know that already. We know that this is 90 and that is 90. But you could have used the fact that it's 3 times 120 divided by 2. This better work out, okay? Or else I'm in trouble. Drum roll, okay? So I have 540, that is 180, right? I'm just gonna double check here because I need to get this right. Yep, it's 180 divided by 2 is 90, right? Ta-da! So regardless of how you do it, you're gonna get to the same conclusion. Okay, homework. I want you to try B down here, this one. And let me just see in the workbook real quick. There's inscribed shapes in here. I want you to work. If you want to review for the test, there's a booklet at the end. Page 24, all the way. Some of them are really short, guys. Some of them are not long at all. It's 10 pages. You're like, whoa, right? So you go pick the ones that are most difficult to you, perhaps. And that's going to help you for test review. Okay? I will post the key. Thank you very much, guys. I hope you